Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet every month, typically every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, whether it's software as a service, platform as a service, or infrastructure as a service. You can find all the meeting information for both present as well as past events posted on meetup.com at the link listed below. We would like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes that will be given using the evaluation forms. I'd also like to thank the .NET Foundation for sponsoring the Meetup website and NIS Technologies for providing the recordings. A special offer from Manning.com. You can save 35% at Manning.com. Discount code MTPCLEC21. And the link is listed at the bottom of the slide and will be shared in the chat window shortly. A couple of general pieces of information. Please keep in mind, first and foremost, participation is encouraged. As we always like to say, the only stupid question is the one not being asked. So feel free to jump in at any point with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to prevent any background noise. And like I said, we like to keep it casual but organized, meaning jump in with questions or comments, but we want to give our speaker enough time to go through the demos and the slides. And lastly, the presentation will be recorded and posted on YouTube in just a few short days to allow for editing. And this brings us to our featured presentation. And with that, it is Zach Gardner. And Zach, let me go ahead and make you presenter.
Thank you very much for inviting me and having me here. I am Zach Gardner. I'm a senior consultant out of Kansas City for Keyhole Software. We typically do consulting in, Kansas, Missouri. We have some clients up in New York City. That's actually the client that I'm on is a large hospital there. And then California, Texas. Nothing in the Cleveland area yet. Give us a little bit of time. We do more advanced software consulting than just typical staff aug. People typically bring us in because, something that they want to do is very complex, like SignalR, and they need people that, have done it before, that kind of know the ins and outs of it. So my spiel is always, I am a very pragmatic architect. I would much rather have working software than trying to achieve perfection. What we do as software engineers is definitely different than a chemical or a civil engineer. We get 80% of the way and we're like, let's try it out. Let's test it in production. Let's see what happens. I'm also not here to sell a SaaS product or a device. If anyone ever comes to a presentation and says, hey, here's this, big, long problem, and then, pay me $15 a month and I'll take it away. They're selling you something, you kind of got to be sketchy towards it. And then also, I like to talk with software developers and engineers and architects, less so enterprise architects. I more like to dig into the people that actually help develop applications. I think that, for me, is the more enriching experience of being a consultant, is, seeing something, an idea make its way into production over, the course of time. So before I dive into SignalR, I think it's important to look at a business problem that we're trying to solve, and then sort of talk ourselves into how we solved it from a technical standpoint. So the hospital that I work for, and really this goes for any hospital that you deal with that's large, they'll have a call center, and patients will receive a phone number that they can call into if they have questions, or something's just not right and they want a second opinion. When they call in, that call center agent used to have, these big phones that sit on their desk and would, ring like they were huge. But now in COVID, a lot of them are going virtual, to where a lot of these call center agents don't work in a large phone bank anymore. They work at home, and they will have what are called soft phones. You can think of it kind of like a digital phone, to where they still have a headset, that part's still there. But when the phone call comes in from the patient or from anyone, it rings on a desktop application, like they have something actually installed in their laptop. And that's what's connecting them to their headset And then they get to see, the phone number of the person that called in, which campaign they dialed into, because a lot of times they'll have different inbound phone numbers for different use cases. Maybe they give one to Medicare versus non-Medicare, a whole bunch of, variants there. And then they have to, once they receive the call, do a little triage, talk to them, maybe look up some things, but then they have to document what they talked about. And so the problem is that the information that they're getting on their soft phones, who's calling in, what number they're calling in from, that doesn't feed automatically into whatever application they're using, typically a web-based application, to document the call. And it's difficult because it's a desktop application that would need to talk to a React or an Angular or some browser-based application. How do you get the two to be able to talk to each other? That was the problem that we were tasked with solving. Every soft phone sort of does it differently, but in general, they have a way to make HTTP calls to some service. It doesn't really matter what, but some service when a phone call is received by an agent and when a phone call is ended, either by the agent or by the caller. That API call can include things like the phone number, the time when the call came in, as well as, they call it everything slightly different, but it's like the agent ID, like the ID of the person who actually received the call, like the call center agent. That information can go into an API. But how do you get that information from the API to the client? Because, in our desktop or our web applications, we do request and response. It's not like we have this thing sitting there that's constantly saying, hey, did I get a phone call? Hey, did I get a phone call? Hey, did I get a phone call? You could set it up like that. And I have set it up like that. I think the last time I did one of those long polls was probably 2009, 2010, somewhere around there. And it works. It's not very efficient and it really bogs down your server, but you can do it like that. What you can do instead is use Azure SignalR service to create a hub between the browser and your server. So if you'll imagine, the API call goes from the soft phone up to your API. That API publishes a message up to a SignalR hub, and then that message can be received by that desktop, like by the browser running on the desktop, without it explicitly asking for it. It's just sitting there receiving this information as it gets pushed to it. And then the last piece of the puzzle being showing something to the user saying, hey, this is a phone number that just came in. Would you like to search to see if there are any records tied to this phone number? Or, oh, well, they're calling in for this particular campaign. Would you like me to pop up a slightly different screen than I would have shown otherwise? Without bridging that gap between the desktop application and the browser application, it's really up to the user to enter in the information. And every single second that they're on the phone with a patient, maybe they have issues for behavioral health, like maybe they are, having suicidal ideations. You don't want your users sitting there doing things that are not contributing to the health of the patient. So you want to automate as much as you reasonably can for them, and allowing those messages to flow back and forth only helps them. So SignalR, as you could kind of tell, it's a bi-directional method of communication between, I wouldn't really say a client and a server, honestly. That's a very typical AJAX sort of mentality. I would say more between a producer and a consumer, except that the producer can also consume messages and the consumer can also produce messages. So it's really just a pipe where you can push stuff and then receive stuff. So it's very different than when you're doing AJAX. Because when you're doing AJAX, like let's say you're on Amazon and you click on a book, to use an example from Amazon, back when all they sold was books, you would have an AJAX call go out saying, give me details of the book. And then when the response comes back in, you know where you're at in the application because you as the client, the browser, have requested that information and you're getting the information in a context that you're expecting. With a bi-directional pipe, you could receive messages for something that maybe was 10 clicks for the user ago. How do you appropriately handle that on the UI? Or on the receiver side, if you were to, if the UI says, hey, give me this, and then give me that, and then give me that, and then give me that, how do you handle race conditions? How do you handle all the fun stuff that comes along with being able to receive a massive amount of information and different types of messages? And there's really, from a producer and a consumer standpoint, there's really two flavors, I guess is the best word to use, for how these messages come across. When a producer sends a message, it can either send it directly to a client or it could send it to a group of clients. So a client would be an individual when their browser opens up, establishes a connection with the Azure SignalR hub, and it identifies itself by some unique ID. Maybe it's a GUID that represents the user's ID. Hopefully not an auto-incrementing ID. If you're still using auto-incrementing IDs, talk to me later. But something that uniquely identifies them. So when the producer needs to send information to a particular client, it can say, hey, I want to send message of, book has been purchased to this client. Or in my case, hey, call has been received to this particular agent. So it's a very directed message. Not everyone connected to the SignalR hub needs to necessarily receive all messages because they can be directed at clients. The other more popular, well, I wouldn't say more popular way. The other way to do it is to send a message to a group. Maybe you have a group for a call center that represents your front office. These are the people that are able to actively answer calls. And you have a different group for back office. Maybe these are the people that are processing claims, that are still doing some work, but they don't need to receive a message every single time someone calls in. When those users' browsers come online or boot up or initialize, they can join the Azure SignalR hub and say, hey, I'm interested in this group, and that group. So when the producer sends a message, it can say, well, anyone in this group, here is a phone call that just came in, or here's something to add to the queue. And that gets disseminated out to every member of the group. Those are the two basic flavors. It's very different than a traditional AJAX style application. And the tooling, I wish were better in terms, well, don't get me wrong, there's a bunch of libraries that you can use for both the front end as well as the back end to be able to interact with SignalR at a very basic layer. It isn't as well established in terms of, documentation for how you set up your consumer and producer messages. A lot of that stuff you kind of have to do yourself, and that's not bad. Don't get me wrong. I think some parts of software development should be a struggle because you get to learn what works and what doesn't work. But one thing I really wish that it had was something like Swagger. If you're doing API development, you're either documenting your APIs in a living Confluence doc or whatever tool you're using, or you're using Swagger. With SignalR, you're going to end up building something that kind of looks like this, where it allows you to test being able to receive messages as well as send messages from an easy-to-use browser-based application. So in this example, I have two different Chrome tabs. They're both pointed to the same page, but they each have their own individual connection to a SignalR hub. And I'll denote which one it is by the bar that you see on the bottom. So when the bar goes like that, it's on the right side. When the bar goes like that, it's on the left-hand side. It's kind of how I keep things ready. So let's say we want to receive a message. So as soon as my application boots up, I automatically connected to the SignalR hub. So on the right side, I want to say, left side, I want to say, hey, I'm going to broadcast a message to, remember, I can either do a client or a group. So I'm going to say, I'm going to broadcast a message to a client. And the client is this GUID, which is actually my user ID in whatever environment this was. And I want to send a message, and I'm just going to say it's a JSON array with values of another and test. So left-hand side publishes a message up to the SignalR hub. The SignalR hub then says, oh, you want to send a message to this client. I know where this client is connected based on that ID, and so I will send a message to all the clients for that user ID. So then the message goes down to the right-hand side. And so I received a SignalR broadcast, and it was a message from the right or from the left-hand side. Now, the interesting thing, because I am the user on both of those tabs, when the message went up from the left-hand side, it might be inverted depending upon how my camera is showing. It actually went down to the right-hand side and back down to the left-hand side. So you can get bounce backs if you are publishing a message up to the hub to a client that is the same one as the one that published the message. Now, you don't typically do this in a real-world application. You know, if you're going to send a message from one user to another, typically that other user is another user. But it is entirely possible that you'll get a bounce back message, which if you're coming from an Ajax world, that's crazy. You can never get a bounce back Ajax message. The client is the client and the server is the server. But with SignalR, that's how you have to think. You always have to be ready to be able to receive a message at whatever time and whatever the message is. It might be for something that happened minutes ago. You don't know. It might be for some data that you don't have. So how do you structure your UI to be able to handle that appropriately? It's tough. We can talk about that later, but it's really tough to do. It's a mental shift that you have to make. So the other message that I could send is I'm going to send a message to a group. My right-hand side, I'm going to join a group. It's called My Awesome Group, for lack of a better name. And then back on my left-hand side, I'm going to say I'm going to broadcast a message to a group. It's going to go to, again, My Awesome Group, and the message is just group true. So then I publish the message up to my SignalR hub saying, send this message to every connection that has joined this group. And because my right-hand browser is the only one that has joined the hub for that group, it goes down to the right-hand side. I could have had 10 different tabs, half of them on one group, half of them on another group, and be able to communicate between all of those tabs merely by not individually saying, you know, tab 1 or tab 7, but just saying, send a message to a group. And again, if you send a message to a group and you're a member of that group, you're going to get the bounce back. There's nothing that the Azure SignalR Hub is going to do that stops that reflection from happening. And for some scenarios, that might be okay. There's really no rule. It's kind of like Las Vegas sometimes. There's no rules with what you need to do. That message, it could be JSON. It could be XML. I mean, you might be able to do something really strange like SOAP over SignalR. I mean, if you're thinking about going down that road, like, we might want to talk about that, because that is a very strange pattern. But you could theoretically do it. You could put whatever you want to on these messages, and there's nothing stopping you. The creation of the Azure SignalR services, it's so much easier than it used to be. When we had to do this on-prem, and I guess this is why it's Cleveland Azure user group and not Cleveland on-prem user group, it was really hard to do these creations of these SignalR clusters. It worked if you only had one server that was your SignalR hub. But as soon as you needed to horizontally scale your application and you needed to deploy it to have, 4, 5, or 6 of them all working together, what you had to do is introduce what's called a backplane. So a consumer might connect to one instance of a hub. A producer might be connected to a different instance of the same hub. And when the producer sends a message saying, hey, send this message to this client, that client might not be connected to that SignalR hub, that instance of that SignalR hub. So the backplane allowed it to go up, figure out where the client was connected, down to that instance, down to the client. The Azure SignalR hub takes care of all of that for you. Microsoft makes things pretty easy. This is pretty easy. There's really not a lot that you have to configure with it. There are some caveats. I'll get into that. The first caveat is what service mode you're going to use. The default, thankfully, is called default. I love it when they do that. It roughly equates to an always-on service. So if you think about your function apps or your app services, there's that option in there for, always on, true or false. When you leave it on, it will send a heartbeat in the background that keeps it alive and makes sure that even if there's no activity, it's not turning itself off. It's not going stale. Serverless is the second option that you can choose for the service mode. Even in the Azure documentation, it says I wouldn't recommend it because it's a not always on option, meaning if you have a lull in activity and then you have a new client that comes on or you have a new connection that tries to be made, there's no guarantee that it's going to succeed. So you have to build in retries. You have to be a lot better about how you're publishing the messages, how you're consuming the messages, and how you're connecting to it to account for it maybe not being around when you're there. And it's not really serverless in the sense that a function app is serverless. Not the best choice of name. I'm sure Microsoft is good at a lot of things. They're good at naming things. They're even better at renaming things. And I hope they really do rename this one because serverless makes little to no sense. The last option is what they call classic mode. And I equate it to gas station sushi because it's an option. You can pay $5.99 and go get some gas station sushi, but it's not a real option. You are not going to enjoy yourself afterwards. So just avoid it. When in doubt, use default. When it comes to tiering, there's 3 tiers. If you're just wanting to trying it out, free tier, perfectly fine. You'll run into no issues. Standard and premium, there's not a ton of difference between them, honestly. I mean, of course, the premium costs $15 more a month. But if you look at the throughput, the number of connections, the number of messages, that SLA, we're talking maybe an hour difference there. It's really not a lot. And notice that it is, 1,000 connections per unit, and then a million messages per unit per day. On the very bottom of the form, you get to pick how many units there are. And you can scale that up. I believe if you scale it up all the way, you get 100,000 connections that can happen on a single Azure ServiceR hub simultaneously, which, I've worked on some large applications, but I don't think I've ever worked on an application that has 100,000 concurrent users. And then I think when you scale it up to, you get 100 million messages per day when you get to it. That is a lot of messages. And this is kind of what the Terraform configuration looks like. Any DevOps person worth their weight in salt will be able to spin this up very quickly. There's not a lot of configuration that you need behind it. When you get into things like networking, it doesn't have the ability to join a VNet or a subnet like some of the other resources do. What it does instead is it gives you a private endpoint. So at least you have a way of accessing it that is segregated at a network level from the public internet. And if you're communicating sensitive and confidential information to and from the SignalR hub, always have that additional layer of network security, along with all the other protections that you put in place for access controls and security controls. So when it comes to tiering and really how you manage that SignalR hub and how you structure your application, it's a function of two variables. How many concurrent connections are you going to have? And how many messages per day or per hour are you going to have? That affects how many units you want, but it also affects how you structure your hubs. So when I say that a browser comes online and connects to an Azure SignalR service hub, that last word, that hub, is very important, because you could have 500, if you wanted to, I'm just making up a number, different hubs running on the same SignalR service. Just as if you have an API, you could have 20 different controllers with 50 different methods per controller, all running on the same function app or same web app. So it's decouple in your mind the SignalR service from the hub. The hub is where the messages go back and forth to, and the SignalR service is sort of like where they're hosted within. And the communication between the producer and the consumer happens at the hub level. That's an important nuance, because there's a really bad way of setting up SignalR. One of them, you can shoot yourself in the foot so many different ways. One of them, if you have really, really, really granular hubs, a hypothetical real estate application. I mean, I've never worked in real estate. I've done healthcare, I've done education, I've done finance, done energy. I've never done real estate, but I imagine that in the real estate world, listings are sort of their big noun if we're thinking of domain-driven design. Everything in the application revolves around that noun of a listing. And a listing, the real estate agents probably want to know when a new listing comes available, because they want to be the first to get their clients there. They want to know when a listing goes under contract, to where it's like, don't even bother driving by that house anymore. And then finally, when a listing gets sold. You could, there's nothing stopping you. You could set up 3 different hubs for that use case that all point to the same Azure SignalR service. You could set up 3 different Azure SignalR services, each with one hub. The bad part about doing that is every time you connect to a hub under the cover, that's its own WebSocket connection. And you only have so many resources. Like, our computers are nice, but we have a lot of other things that are going on there. We have a lot of other network traffic that's going on there. And the more and more that you put and have these different lines all trying to operate in parallel, you're really reducing your throughput. A better setup for this would be, if you're a large organization, maybe you have a different SignalR service per application. And then within an application, you have one SignalR hub inside of that SignalR service. You might have 2. I might be able to buy that, but then you probably should split it out. It probably should be different applications. So in this correct, thumbs up, setup, you have one SignalR, Azure SignalR service. You have a hub for listing. The producer sends a message on the listing hub saying, new listing, or listing is under contract, or listing has been sold. That means you have one WebSocket connection per browser session instead of 3 per browser session. So if you remember back to the number of connections, if you have 3 connections per browser session, that's going to eat into your connection limit. And you've already gone down from being able to have 1,000 concurrent users to 330 concurrent users by having all those different hubs create their own different connections. So if you are going to use SignalR, I would really recommend having one Azure SignalR service per application, and then one SignalR hub per Azure SignalR service. I really don't have a lot of good reasons to have multiple hubs per application. I think you probably get away with putting all the messages on that one hub. What you can put on those messages, it's very free-form, very avant-garde, somewhat like the buildings that are on the left side of this slide. You can put whatever you want on those messages, which is great if you're a single developer with an amazing and infallible memory. If you're like me, where you forget things and you kind of need to put practices and structure around how you send the messages and best practices, you probably want to enforce a little bit of, not necessarily hierarchy, but maybe rules or best practices around what you're doing. So when we publish a message onto SignalR, and when we consume a message off of SignalR, the developers don't do that directly. We have sort of intermediary classes where they have to, when they're publishing a message, provide certain information. And then when they're consuming, their callback gets invoked with those particular pieces of information to make sure that both sides are in sync. The three that we always include are a correlation ID. For every message that goes across, it gets a unique GUID, which is really nice when it comes to debugging, because if the producer logs, hey, I sent a message with this GUID at this time, and then all of the consumers, when they receive the message, log out to whatever you're using, App Insights, hopefully, or the Elk Stack, that's fine too. Hey, I received this message with this correlation ID. You can see exactly who received the message and when. A message also needs to include, for us, a topic. Just like an email. When you get an email without a subject, I mean, that's like getting a call on your phone with no caller ID. It's like, I'm not going to answer that. Like, that's not cool. You have to have some context around what the message is before you actually look at the message, because that could help you route the message in your application to the right place. There's only so much you can do when it comes to the topic. You need to have whatever you choose. I'll say this, whatever you choose, as long as you're consistent about it, it's the right choice. If you are inconsistent, it doesn't matter what you're choosing, it's the wrong answer. You have to have some consistency with how you do the topic. So in the real estate application, are you going to do listing dot under contract or under contract dot listing? Me personally, I'd probably do listing dot under contract. I kind of like noun dot verb or noun dot adjective. I don't remember what part of speech it is. As long as you have that hierarchy, and as long as both the producer and the consumer are clear about what the topic is and what the payload is, you're fine. You could put that in a Confluence page. You could put it in a Word document. You could put it on a sticky note, next to my children's beautiful artwork back here. You can do whatever you want. That's fine. As long as those two are in sync and they know what's going across, that's fine. Payload for us, we always publish JSON messages. It's 2022. There's no reason not to use JSON at this point. And now, the last thing that I want to go through. Whenever I go to a presentation, someone talks me into using some new technology. I get really, really excited about it. Like, I'm trying to think of all the ways that I can use it. If they don't tell me the pitfalls, I know I'm going to have to find out about those pitfalls myself. And because I like you all, it's a beautiful fall night here in Kansas City. I'm feeling very thankful, feeling very generous. We'll let you in. We'll secret all the other things that I've already talked about different ways that things can go wrong with using SignalR. Not even Azure SignalR in general. It could be the on-prem one. Where is it right to use and where it is not? Where I would not recommend using SignalR or WebSockets as a general slash and burn approach to replace Ajax. I have been developing long enough that I remember having to code up Ajax calls by hand because I didn't have jQuery. jQuery did not exist. And I remember what a light bulb moment it was when I fully grokked what Ajax could do. It's an extremely powerful tool. It's just a tool, though, just like SignalR. SignalR is just a tool. Ajax is really, really good at, if you are in the context of something on your web application, being able to load pieces of data at a time, just in time, get that information back and paint it in. We've gotten really, really good at doing that, especially React. I think React is my favorite way, React with Axios, to do it. SignalR, if you're producing a message from the browser, your client is the API, it receives the message, does some processing, like maybe does a database call or what have you, produces a message directed back at the thing that sent it. I mean, you're really just doing Ajax over SignalR. And I don't think that that is a very appropriate place to use it. You know, we've already got a tool that does the job really well. The only way I would really be convinced that that is a good option is if you went full and you only did SignalR, you did absolutely no Ajax. You would be consistent, so you would get points on my consistency scale, I guess. But there's not a lot of advantage to it. I mean, we have this rich and beautiful ecosystem around API development for, web API, like function apps with HTTP triggers. Like it works really, really well. So like, why do you want to mess with something that works well? And to know when something goes wrong in SignalR, that's also where it's another pitfall. You have to, after the SignalR service is created, go through the Azure Monitor and set alerts for capacity. If you're at 90% connection saturation for 15 minutes, you've obviously undersized how many units you have, and you need to bump it up. What I don't like about Azure SignalR service that I do like about a lot of their other offerings, like web apps, it's really good at being able to set scaling rules. Like web apps, you can have it scale up when it reaches a certain percent threshold. You can have it sustain there, and then you can have it scale back down slowly or quickly. Set minimum and maximums. Like, it's great. They've done a lot of stuff in web apps to be able to handle fluctuations in load. SignalR, it doesn't have that. I mean, theoretically, I think you could set up some maybe logic apps to be able to receive that kind of telemetry from monitor and then automatically scale it up and down based on the units. But it's like, do you really want to be in the business of doing that? Or do you want to defer to Microsoft doing that? Like, I would rather defer. I would rather pay Microsoft to solve the stupid problems that I don't want to have to worry about, so that I can focus on knowing my users, knowing my business better, and being able to develop software that actually helps them. I don't want to be able to have to do that kind of mundane stuff. I don't want to have to write another form builder ever again. So that's one of the pitfalls that I see a lot of people fall into. The other is what I kind of talked about before. Messages are so freeform. You really, really have to be disciplined and principled about how you document what the producers will produce so that the consumers know what they can consume. And no matter if the producer is the browser or if the producer is the API, you have to have some clear documentation somewhere. It doesn't matter where. As long as someone can access it any time of day and update it regularly, you have to be able to know what is going on either side of that pipe. And then lastly, kind of wrapping it all up, SignalR is not a one-size-fits-all tool. I mean, it was really good in the scenario that I used it. And Azure SignalR service helped us scale in ways that we wouldn't have been able to do on-prem, and having to manage backplanes. Like, you could do Redis, you can do my SQL Server on-prem. Like, there's a lot of ways to set those backplanes, but it's not fun. I don't want to have to do that. I want to learn what my users need and develop for that particular use case. I want to work on applications, not on platforms. So that's my shtick. I mean, I'm a big fan of it. I think that it has a lot of different use cases. And I think that there are a lot of things in software development that, have pros and cons. And it's helpful a lot of times in these kind of forums be able to see and to hear and to talk through with someone that has used these things before, that has seen what works well and maybe what doesn't work well. So if you're craving more, if you want to contact me about different things that you're curious about, if you have ideas for other things that we should dive deeper into, maybe different problems that your development team has or different deficiencies in certain technologies, how would you architect one with given constraints versus another that has different constraints? Drop us an email. We love helping, and this is why we started back in like 07, 08. We love helping people solve their business problems through software. And the more that we can automate, the more that we can take people out of the equation and allow them to do the things that people do really well and allow the machines to do the things that they do really well, I think that benefits everyone in the end. So I will pause for any questions and also to take a drink of water.
Hey, Zach, I was curious, do you have any technical or any code implementations that you can go through?
In this particular setup, I only can describe kind of in vague terms what we did. If I wanted to go through and actually show like the code for what we did, I wouldn't be able to share that on like a recording or anything. That's the tough part. No, I think for a follow-up, yeah, I probably could. It's honestly like crazy simple to get a lot of this stuff set up. The devil's really in the details for how you document it, how you set up your hubs, and then how you use it on one side or the other.
Okay, and the other question I had for you.
Yeah, good.
You started off where you were saying how they now have soft phones where basically the calls are taken over a PC. So essentially this is voice over IP. How did you implement that from a technical aspect using SignalR? I mean, obviously there were packets coming across and you're storing JSON in the hub. So how did you convert voice over IP into JSON?
Thankfully we didn't. So like what happens is you call a phone number, it gets routed through like a phone queue. There's like weird terms, I don't remember all of them. But eventually it lands on someone's desktop application. That desktop application client had to be configured to say when a phone call comes in or when a phone call is dropped, send an API call out to my API. It does that independent of the actual like the packets, like the VoIP that is going back and forth between the agents and the person that's calling in. So all we really got was an API call that had the metadata about the call. We didn't actually get like the WAV file or whatever they use for voice over IP of the call. And that's all we really needed. All we really needed was who the agent was that picked up the call, what phone number they called into, and what phone number they called in with. And that was enough for us to trigger our application to show the information appropriately to the user without them having to, type anything in. It showed it to them. And from a desktop application through a web application.
Okay. Thanks for answering those questions. Does anyone else have any questions for Zach? All right, looks like it's a wrap, Zach.
Awesome. Thank you so much. This was fun. I love talking to people about technology. It's one of my 10 favorite things to do.
And thanks for joining us. I just have a couple of concluding slides before we adjourn for the evening. So let me go ahead and present my screen. All right, so thanks again to Zach Gardner for a great presentation on SignalR and integrating it with the phone application. As far as resources, so I will be posting links for the YouTube channel as well as for the blog post. And the blog post will contain technical events that we'll cover in just a second. In addition, I'll be posting the link for the eval form. And if you would please take a minute to fill that out so that we can offer some constructive criticism to Zach. And let me go ahead and grab these links. So all those links are posted into chat. And to go through it in more detail, Special offer from Manning.com. We're getting 35% off from Manning on a selection of books. Discount code is MTPCLEC21. And the URL is posted there on the bottom as well as in the chat window. Regarding upcoming technical events, on November 17th is the Great Lakes Users Group.net, and that they're going to be meeting online. And you can find the meeting information on meetup.com/glugnet. And on November 21st is the Cleveland C# VB.net user group. And again, that's another group meeting online. And since it's going to be Thanksgiving this month, November 21st will fall on a Monday as opposed to our typical fourth Thursday. Regarding conferences, if you haven't already heard, .NET Conf has been going on for the last 2 days, and it's still going on for another day. You can join free of charge, .NETconf.net. In addition, GitHub Universe started today and will be continuing through tomorrow, and the link for that is githubuniverse.com. Regarding job openings, Tech Systems is always looking for positions, or they have positions available. And so you can find those openings at techsystems.com/IT-jobs. And if you're hiring or if you're looking for work, please feel free to enter it into chat or send me an email. And speaking of which, my contact information, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And my blog, samnasser.blogspot.com, where I'll be posting the technical events that we covered. And lastly, if we're not connected together on LinkedIn, I invite you to do so. And so with that, thanks again to Zach, and thanks for all that joined us tonight. Look forward to seeing you next month. Good night, everyone.